All right, so here's the graph of F. We talked about how this is a turning point and this one is not a turning point, and good. It is not a turning point at 1, and you can tell because it doesn't change sign right here. So it stays positive on both sides of 1, which is why this is not a turning point. It just ends up becoming a flat part. So both of these points are very, very important to have on your graph. Again, the y values are not as important as the x values. So as long as it occurs at -4 for this turning point and over here at 1 for this turning point, then you would be correct in that. And then concavity. Let me highlight some stuff for concavity. Concave down I'll highlight in blue. So let's see. It looks like there's a point of inflection. Remember that points of inflection come from turning points on the derivative. So let me highlight these in a different color actually. Let me do them in purple. Here's the turning point on the derivative graph. Oops. Here's a turning point on the derivative graph. What x value does that look like it's at? -2 maybe? Alright, so over here at -2 there's a point of inflection. And then there's a turning point right here again at 1. So 1 is actually a point of inflection as well. Or actually, I'm sorry, I lied. It doesn't change from... Actually, no. I told the truth. There we go. So let's look at this. So red turning points or horizontal asymptotes. Purple, points of inflection. Okay, so there's 2 points of inflection and there's 2 horizontal asymptotes. So now let me highlight in blue. Concave down, right here. Did you guys draw that piece of your graph concave down? Alright, concave up, I'll do it in orange. Concave up, right here and right here. And again, I know that from the original graph because it was increasing here and here, and it was decreasing right here. So that's how you can kind of see the pieces correspond here. If the first derivative, is decreasing, that means it's concave down on the original function. And if the first derivative is increasing, it's concave up on the original function. So you can kind of see that there. All right, I see some of you guys writing it in now, and that's okay, honestly. It's been a crazy, crazy week. So if you didn't get a chance to do it, I hope that it's making sense now. But if you did get a chance to do it, how did you do on it? Mostly correct. Okay, good. And again, the y values don't really matter as long as the concavity is correct, as long as your points of inflection are correct, and as long as your turning points or horizontal asymptotes are correct. All right, do you guys have any other questions for me on F? All right, let's look at the other one I told you guys to look at. So that was F. I also told you guys to look at, we did G together, right, in class, on the video? I think I told you guys to look at H, right? All right, so here's what H should look like. Oops, too far. There we go. So let me highlight the points that are important, and I'll try to do them in the same color as last time so that it sticks with you. Turning points. Remember that turning points come from zeros of the first derivative. So I have a 0 at this x value. What's this x value? -4. So notice that here at -4 I have a turning point, which means that here at -4 I should have a turning point. I have another 0 right here. What x value is this? 3. So if at 3 I have a turning point, then over here at 3 I should have a turning point. So it looks like this graph is a little off. Here, let me erase what this guy did because his graph is a little off. All right, so we'll put our own turning point. So there's a turning point right here at 3. Remember that there are points of inflection wherever we have a minimum or a maximum. So notice up here, I'm increasing. That's going to be concave up. And then all of a sudden I start decreasing. That's concave down. So here I have a point of inflection. What x value is this at this maximum? 1. Perfect. So I should have a point of inflection at 1. So here there's going to be a point of inflection. And then last but not least, concave down after 1, concave up before 1. So let's see, concave up, we'll do our graph in black, how about that? Concave up before 1, And then all of a sudden there, at that purple dot, it changes to concave down. So it should be concave down after 1. So it should look something like that. And let me highlight so you guys can see the correspondence. Is it starting to make a little bit more sense now? Noticing where the zeros of the first derivative relate to the turning points of the original function, how the turning points of the first derivative relate to points of inflection of the original function, and how increasing and decreasing relate to concavity on the original function. Do these charts help you guys, or is it helpful more to just do the highlighting? Highlighting, yeah, I feel like highlighting kind of helps a lot. These charts can be helpful, but it could get a little confusing, so make sure you guys bring highlighters to help you. Also, for the AP test, you're allowed to write all over that book. So if you guys want to bring 15,000 different highlighters, you can bring 15,000 different highlighters, if that helps. All right, so that was H. Do you guys have any other questions on H? Beautiful. Let's look at the next one. So I think we did, which one did we do together, A or B? We did B together. All right, so let's do A then. So again, let me get my colors back out. So remember that a 0 on the first derivative is a turning point on the original function. Can you guys tell me, just by looking at the first derivative, could you tell if this was going to be a maximum or a minimum? And how can you tell?
If it's positive and then goes to a 0, that's a maximum. But if it's negative and goes to a 0, it's a minimum.
Good. If it starts positive, goes to 0, then goes negative, that means that it was increasing, then went to 0, then went decreasing. So that's a maximum. If it was the opposite, if it started negative, then went to 0, then positive, it would have been a minimum because it would be decreasing to increasing. So that's how you can tell just by looking at the graph whether or not it's going to be a max or min, is if it goes from positive to negative or from negative to positive. All right, do we have any turning points on this graph? Do we ever change and see it go from increasing to decreasing? This graph, does it have any turning points? Or horizontal tangent lines? I don't see any turning points. It's decreasing the entire time. Do you guys see that? This thing is always, oops, that's not what I wanted. This thing is always decreasing. So that means the entire thing is concave down. And look, you guys can even see that right here. The second derivative is negative the entire way, concave down the entire way. So notice that my graph is concave down the entire way. There happens to be a vertical tangent line right here, so you guys are going to get a vertical tangent line right here in the middle. But that doesn't necessarily affect the concavity because it's still negative the entire time. So our graph looks like this, concave down, increasing first, decreasing second, so that we know this is a maximum. This is not a point of inflection again because the inflection does not change, but also because this point right here, because it's a vertical tangent line, it's undefined. So the second derivative actually does not exist at this point, which is why, again, it's not a point of inflection. All right, good on that one? Let's keep going then. I think there's one more that I had you guys do. Which was the last one? C? Is that what you said? All right, let's look at C. Oh my gosh.